Hi everyone and welcome back to my channel in Economist. So in the previous few lectures we were discussing in detail relations and functions. We have solved multiple questions on that, and in the previous lecture we have seen some special functions. Particularly we have gone into discussing monotonic function, even function and odd function, right? Now we will continue with that, and this will be our final lecture on the topic relations and functions. So let's start with this. Let's discuss what is a step function. Step function is also known as the greatest integer function, and it is represented by the box, right? If x is box x, this third bracket implies box, right? If x is box x, is the greatest integer less than or equals to x. Let's look at some example to explain this. What will be the box value of 1.15? It will be 1. Let me show you a trick to do this. Whatever box value is given to you, I want you to plot it on a real line. So it is infinity, it is minus infinity, so just plot the value. Suppose this is 1, this is 2, this is 3, this is 4. Now where will we find 1.15? 1.15 will be somewhere here, right? 1.15. So whatever value is given to you, just find what is the integer value on the left hand side of that number. It is 1, so the box value of 1.15 will be 1, right? Just find the left integer value. Similarly, we have 4.56 something something, so it will be somewhere in between 4 and 5. Suppose this is here 4.56, this number. What is the integer on the left hand side? This is 4, right? So the box value will be 4. And if you have an integer value inside box, that box will give that particular value only. So box of 0 is 0, box of 1 is 1, box of 2 is 2, so on and so forth. Box of 50 is 50. Similar thing will happen if you take negative values. So this is minus 1, minus 2, minus 3, minus 4, right? So you have minus 3 point something, so it's here. What is the immediate left integer? Minus 4, right? You have the value here. Immediate left integer is minus 4, so box value is minus 4. Now let's see how we will plot this on xy plane. I have taken the example of box of x, where x belongs to real numbers. Then what do we need to do? We need to consider some specific range, and then we will see the box values and plot them here, right? Let me take another color. So if the x range we are considering to be 1 to 2, 1 to 2, so this particular range where 2 is not included, 1 is included, then the box value will come out to be 1. This is the box value, so plot here. Functional value will be 1, right? Now take the second range. This is 2 to 3, 3 is not included, so in 2 to 3 the box value is 2. And these values are not included. 2 is here not included, here 3 is not included. Now let's go about 3 to 4. In this particular interval the value is 3. 4 is not included, so do this. And in the next 4 to 5 you will have this value is not included. So you can see that it's a step like function. Why it is called step function? Because the graph looks like steps, right? Parallel steps. Now you can do similar things here. What we will see, minus 1 to, this will be 0, minus 1 to 0, the value is here, minus 1. Minus 1 is included but 0 is not included, so do this. Then you have from minus 2 to minus 1, the value is minus 2. It will be a parallel line, pardon my drawing. Minus 2 is included but 1 is not included, and you can keep on doing this, right? So the steps will be here and then it will come here. This is how you draw the step function, and it is also called the box function or the greatest integer function, right? Then you have something called the polynomial function. This is the most used function that we often encounter. So in polynomial fx, the functional form is this: a n x to the power n plus a n minus 1 x to the power n minus 1 plus a1x plus a naught. Now here this a naught is a particular constant term because it is not associated with x, or you can consider x to be with the power 0. This is x to the power 1, this continues x to the power minus 1 and x to the power n, and this power determines the degree of the polynomial. So this is an n degree polynomial, right? Nth degree polynomial function has this particular form. These are particular terms in the polynomial, and plus is the operator, and this is the exponent. And we have certain constraint on the exponent. The exponent in the polynomial should be a whole number, and we will see examples now that will give you an idea. So you need to identify which of the following are polynomial and which are not. So here this is simple polynomial of degree 2. This is also polynomial. This is linear function. This is a quadratic function. This is linear function, and this is cubic function. So all these functions are polynomial functions. And here if you see these particular 3 examples, here the exponent is negative, here it is fractional, and here you have a division operator here. So all these 3 are not valid polynomial. If you look at this particular constraints, then you will understand that an minus 1 up to a naught, this has to be real numbers. An can't be equal to 0. If it is 0, then this nth degree term will be gone and this will not remain an nth degree polynomial. N is a non-negative integer, right? Non-negative integer. So here this is negative, that is why it is not a valid polynomial. And exponent term has to be a whole number. Here it is half, which is a fractional number, so it is not a valid polynomial. I hope this is understood. Then let's quickly go into the rational function. So it is in the form fx gx upon hx, where the denominator can't take the value 0, and gx and hx are polynomial functions, and if the function is in this particular format, it is called a rational function, and this is a valid rational function example. Then we have something called the exponential function. It is in the form fx is e to the power x, where x is any real number, and e to the power x has the expansion like this, Taylor series expansion. We can do this in another video, how we can derive this, but here you need to know that e to the power x takes the following form: 1 plus x upon 1 factorial plus x square upon 2 factorial, so on and so forth. And if you want to plot it graphically, I have taken some particular values and in the domain, and I have founded out the range in this way and plotted it in xy plane. So what you see here is that if x value increases, the y value increases more rapidly, right? For a small increase in the x value, you have massive increase in the y value. Also you can see here that there is no x intercept term, because e to the power x is not equals to 0 for any value of x, right? But the y intercept is 1 because e to the power 0 is 1. So if x value is 1, x value is 0, y value is 1. So you have gotten y intercept, but there is no x intercept, right? So this is the exponential function format. From exponential function, you can also find out the logarithmic function. This should be logarithmic function, right? Logarithmic function. So you start with exponential function, y is e to the power x, and then you take log on both sides, and you end up getting this. X can be written in the form log y to the base e, thus y can be written log x to the power e. right? And is the inverse function of e to the power x. So if you want to see graphically, what do you see? This is a 45-degree line, y equals to x, and if you have the exponential function as this, y equals to e to the power x, logarithmic function will be just the mirror image of this. So consider this to be a mirror. Consider this 45-degree line to be a mirror. So in one side you have e to the power x function, and in the other side you have log x function. So it's just the mirror image of the exponential function with respect to the 45-degree line. Then we have identity function. Identity function takes the form y equals to f(x) is equals to x. This is the functional form for any real values of x. So for x equals to 2, functional value is 2. For it is 4, the functional value is 4. So it is in this particular format. And the graph looks like this. It's also a 45-degree line. So it's basically y equals to x line. Represents the identity function. And if we go into the constant function, it will be f(x) equals to some particular c, where c is a real number, right? Any real number. This is the functional form. C is a constant. C is basically a constant which belongs to the real number. For each x, you will have a particular c. In this particular graph, you see that f(x) is equals to 4. Right? This can be expressed in this particular fashion. For 2, the value is 4. For 4, the value is 4. For 6, the value is 4. So for any value in the domain, you take any value in the domain, this will give you 4. So the domain here is the real line, but if you consider the range, it will have only one value, which is 4. So in general, if you consider, the range will be only the value c. And here in identity function, what do you have? The range and the domain are equal, right? The range and the domain both are the real numbers. And here in exponential function, you have the range equals to domain. And what else? We have covered everything, right? Okay. Now finally we have the Signum function, and this is the functional form, right? If x is 1, if x is greater than 0, it is 0 if x is 0, and it is minus 1 if x is less than 0, is called a Signum function. Again, if you see, the range consisting of only these 3 particular values. It can either be 1, it can be 0, or it can be minus 1. But the domain consisting of the entire real number line. So you can take any value, the output will be any one of the 3 values, right? For if you take any value greater than 0, the functional value will be 1, which is seen here. If you consider x to be 0, the functional value will be 0, and for anything less than that, the functional value will be minus 1. So this is the general form of a Signum function. And then I have some homeworks for you. You can take a screenshot of this and try this in your free time. And you can also ask me your doubts in the comment section. I will give you reply. And here you have some more questions. You can try them on your own in your leisure time. And I hope that you find this video helpful. If you have any doubts from relations and functions, you can ask me. You can also join my WhatsApp channel for the solutions of the homework questions. And if you haven't subscribed my channel, then do subscribe it and give me a thumbs up if you like my content. And let's meet you in the next lecture. Thanks for your time.